Hey, this is MJ, call sign KW3KW, and welcome to another episode of Ham Radio Made Simple. Today's episode is on solar power, episode number 35, and this is using solar as a backup for HF ham radio. If you are getting value from these videos and would like to support the channel, please hit the like and the subscribe button. Others are finding this channel easier because of your help, and I just want to say thank you. So, what is the agenda for today? I'll talk strictly about what most people do with a battery only setup, no solar. And then I'll talk about why consider solar, about the basic solar components you would need to have something that's portable and mobile. I'll get into the basic setup and my setup, as well as my handouts, which are going to go into a lot more detail. And at the end, I'll do a summary and give you a health update. I'm deferring this to the end so I don't waste people's time who don't even know I have a health issue. So let's get started. So when we talk about HF battery setup with no solar, what does that look like in a mobile use? And why are people in ham radio using it? Well, for things like parks on the air, summits on the air, camping, you can bring your own battery and essentially just have some wire clamps or alligator clamps that go onto an Anderson power pole connector, and essentially then you can connect to your rig. There are specialty batteries like the BioEno battery, which is used for ham radio a lot, and it already comes with the Anderson power pole connectors onto it. That makes it really simple to use, and that's what I have. I have several of those. You can also do the direct wire to your battery through the firewall. And I've done that with my zip wire, and it comes out inside, and I now can use inside my car my FT891 and run off my car battery. So it can be a direct connect to a car battery that's in the car, or a portable car battery that you can take out, put on a park bench, for example, or wherever you're at, and connect to the battery directly. And that's pretty much what people are doing today with no solar. Now, they'll typically recharge the battery at home, and they're not worried for being out for too long periods of time and pulling too much power. A lot of people do QRP, low power when they're outside in a mobile environment. But let's talk about the HTs. I'm just kind of a little bit of a one-off here, but if you're looking at your handhelds, for example, most people don't try to do like a solar system with this whatsoever. They just use extra batteries to swap out. So, like for example, on my Anytone 878, I actually always carry an extra battery, and that's plenty for a full day charge on that. I could also use a DC car charge adapter like this, plug it in, and actually put that right on the phone, right on the handheld, and use that. Or I can actually be charging the battery while I'm driving as I'm going along also. So that's a really, really nice solution if you're using your HTs in a mobile environment. And if you've got the money, you can always use like a portable power station, something like a Jackery, and that's pretty much charged, and you can get some of these that really have a lot of amp hours in it, and just charge your HTs directly off of it when you get the chance. So that's pretty much all I'm going to talk about when it comes to your handy talkies. But let's talk about why solar. Why should you consider solar whatsoever? I'm one of those kind of like the Boy Scout in the sense of always trying to be prepared for the unexpected. And if you look at the current times that we live in right now, there are going to be a lot of disruptions that are going on, disruptions to the power grid in particular. It's happening more and more as we deal with hostile foreign adversaries who are trying to take down our critical infrastructure. But in realistic terms, today, storms, natural disasters do a pretty good job, especially being in North Carolina when hurricanes come in from the East Coast. That side of the state can be without power for weeks. Also, if those who like to follow what's going on with solar activity in the sun, we are due for what is known as a Carrington event that happened back in 1859 that basically fried all of the telegraph wires from a huge CME, coronal mass ejection, that happened, X-class plus flare, that just basically wiped out the telegraphs all around the world. It just wasn't the United States. So we're overdue for that. And the And NASA study found that more than 130 million people would be left without power if an event like that happened today. So again, being prepared. Hackers knocking off power offline, that's going to continue to be the norm. But in my area, about 18 months ago, some crazies shot up some substations a couple counties away from me, and they were without power for 10 days, just from someone using a couple bullets to shoot up a substation. So this stuff does happen, and I've seen it right around me firsthand. When it comes to the basic solar components on a ham radio setup, this is what I'm talking about, ham radio setup, you're looking at batteries that can be very specific for ham radio, like the line of products offered by BioEno that already have multiple Anderson type power pole connectors built into it and the right amperage and size of batteries to do QRP or to do 100-watt power when you're using your ham radio gear. Solar panels you're going to find typically are going to be something more like the foldable one, which you see here, which I have. Mine are the Blue Eddy ones. A solar charger, which is a critical component. And again, I'll break all of that down, what it is, but that's another component that you're going to need. Inverter is optional. I do have it, and essentially it takes the 12-volt DC, converts it to 120-volt AC, and like mine is a 300 a watt pure sine wave inverter, so I can charge my laptops and even HTs and everything right from solar using the inverter right on site. It's pretty cool. In the solar world, they have different type of connectors that are specific to the solar area. And for example, the MC4, which you're going to see right in here, is very common what you use in coming off your solar panels, your typical size solar panels. However, when you come and do your research on the foldable panels, you're going to see that they'll use Anderson power poles like this. And the reason it's pretty big is it's not that they have a huge ham radio world buying this stuff, but the RV market, your recreational vehicle, is huge in using solar within the RV itself. And so that's very common to see these two type of connectors, as well as the T60 and the T90 connectors, which look pretty much about the same. The difference is this is 60 amp, it can go through the wire, and 90 amp. So this is 60 and versus the 90. But you'll see those connectors, especially in your portable mobile solar generators. If we look at what we're trying to do here as far as combining the key components, the order is your solar panels are going to be connected to the solar charge controller. That's going to be connected to a battery. And in the event that you want to be able to take the 12-volt DC current that's generated on this side and convert it to AC load capabilities, the 120-volt AC, then what you're going to need to do is add an inverter. And I'll explain more about how that works. But to keep it simple, solar panel batteries generate more than 12-volt DC and has to be regulated to go into your battery. So that's what it's going to do. It's going to go into your battery, and this is optional. You don't have to do it. And just think of this, when you're getting into solar and you're going to see all different types of battery configurations, we want to keep it at the 12-volt side, not the 24 or the 48. That way we can do direct connects to our ham radio gear right from the battery. So when we look at some of the system component overview in here, solar panels you have basically come in monocrystalline, polycrystalline, and there is a form called thin film lightweight type of panel. I believe it's also mono, but instead of being foldable like this, more rigid, it's a very thin flat layer wafered type of PVC type of plastic that it sits on. Now it lays flat. Now you're going to want to always look for mono. That's the better technology out today. This is the older technology. That's pretty much, it's cheaper, but it's going by the wayside. The thing that you do want to pay attention to is when you're looking at your portable solar panels is if they have a kickstand. Again, you have to find something to lay this up against. And does the kickstand, is it adjustable? Because if you use the solar calculator based on my zip code at this time when I'm recording this, my optimal angle for my panels is 29.4, 29.6 degree angle. It's not flat on the ground. And so depending on the time of the year and where you are, in your location, you want anywhere from like 15 to 45 degrees be able to adjust. Not all solar panels have adjustable kickstands, so be aware of that. Mine do. I use the Bluetti P120. It's a lot more expensive, but I have a whole system at home that I use Bluetti with, so I made sure I standardize on all of my setup for backup solar in here. But what you need to walk away with is look for one that 100 watt, maybe no more than 120 watt, and again, based off your choice of your solar charge controller, that's going to matter. And you want to make sure that the kickstand legs are adjustable. So if we look at the solar charge controller, this kind of thing, people basically take this and put it on a box, a battery box, and be able to connect it together. This is the one I use. I can't remember if it's from PowerWorks or Bluetti, but they're available on both on either site. You can buy them. But essentially what you're looking at trying to do here is to have a connection between the solar panel and the battery, and you want to stop the battery from overcharging. As I mentioned, the amount of voltage from the solar panels is a lot more than 12 volts DC. So it's going to regulate the power in and out of the battery to protect it, and it also stops reverse power back to the solar panel at night. If you didn't have a solar charge controller, the battery would discharge back to the solar panel. So now let's also look at, for example, batteries. Batteries come in many configurations, and I'm not going to go into a deep dive on it. They're in my handouts. But there are three types. You have the lead acid, the lithium, and the lithium iron phosphate. I know people that will love the lead acid. The older people that have been using it for years, they're fine with it. But where the market's pretty much gone is the lithium iron phosphate. It's a much safer battery than the lithium. You don't have to worry about thermal runaway and fire resulting from it. It has more discharges, more cycles, a longer lifespan, etc. And I go into more detail about that in my handouts. But some people will actually take the battery and use it as their main power source instead of plugging in, a power source, 120 volt power source that converts it to 12 volt DC. They just eliminate that and use the 12 volt battery directly itself, which I think is a good idea because it protects against power surges and stuff like that. In the battery world, there are some manufacturers such as Bioeno that's specific to ham radio. And why that's important, they include the Anderson power pole connectors, rather the standard or the larger gray ones, for building for a battery box if you're going to build it. But they also have lower amp hours than the standard batteries that are out there that make it lighter, more portable, and easier to use, especially if you're doing QRP. You don't need to be hauling some, big bad battery around that's really heavy. Now, when we look at inverters, they can be able to use to power a laptop, power your Pi device, a monitor, or whatever. So it's going to take the current, as I mentioned, 12 volt DC to 120 volt AC. And it can easily connect to the battery. You can do it right with alligator clamps onto the battery itself, which you're going to usually get typically like on this 300 pure sine wave inverter. You're able to do 15 amps versus 10 amps off the cigarette lighter when you use a connector through the cigarette lighter, which is usually a 10 amp fuse. Cost you could expect is between $60 to $300. For something portable, the $60 300 sine wave one is ideal to keep in your pack, and it doesn't weigh much whatsoever. So let's kind of walk through a setup scenario here for a 12 volt system. So the solar panels, if they have the MC4 cable connects, which mine do, go right into the solar charge controller MC4 connects, which you get right there. It makes it pretty simple. Then you take the Anderson power poles that go in here, connect from here to the battery. This is actually go down the rings, go on the terminals. Optional is an inline fuse to the battery. You don't have to have it at this point. You definitely want to have it on this side toward your rig. But I happen to have that around, so I basically include that in as extra protection in case there was a problem with the solar charge controller to protect my battery and the equipment down line. Next is the battery's going to connect to the rig control right in here, and it goes out into the rig. And for depending on your solar charge controller and your setup, many times it's called pass-through charging, where you can actually be powering your rig without necessarily using the battery power itself. It's coming right from the source in here. So again, that's optional. The other thing is you can look at is an optional meter in here. It's the incoming and outgoing power. PowerWorks has them. There's a lot of ones that are out there, but just make sure that one side says source, one side's load. So the source is going to be where's the source coming from, which is the solar power panel. If you want my handouts, please email me at kw3kw@mail.com. And this is my setup, and this is a basic setup. So in detail with the price, part, stuff like that, I show you, this is mine. Mine's going to cost more because I have a battery box that I use. I prefer it. You don't have to use it. But even, showing you like for when you get back and you do have AC current at home, you can use a charger in here, but you have to make sure it matches the correct size within your battery that you're using, especially if you're buying smaller size batteries from BioEno. So again, if you want the details of that, please just email me and I'll be glad to send it to you. What were the price on the systems? On the basic setup that I did, this is what's in that document, everything that you're going to see in here. It's about $620. The batteries are not cheap, and the solar panels are not cheap. Those are the two key components. Everything else, is reasonably priced in here. But here's an example for one that's $620. My setup is $1,100, and that's because this box is just $200 alone. I use Bluetti standardized for all of my solar at home. So this is $400 and you can get the other one for, maybe half price of that. So that's the difference in the price is, this, the size of the battery, the using the battery box and using my Bluetti by choice for standardization within my home. I'm just going to take a few minutes here to show you my setup. What you're seeing here is my Bluetti P120 120 watt solar power panel. My battery box, the solar charge controller, I'll do a close-up shot on that here. This is my alpha antenna vertical, that's right up in front, and I'm doing digital with my FT891 and the Yaesu tuner that is compatible with it. So in the next picture, you can get a better view. You can see my battery box. I painted it blue. It was orange, and put the stenciling on it. You can see the hookup, the table and the chair I got off of Amazon. It takes about 30 seconds, or a minute to basically put this table together, and the chair is another about minute and a half. Very lightweight, easy to throw in. But you can see how everything is just so compact and connected. And there's my alpha antenna. So little table where this is where I can do digital. My radio is right here and it's being fed right off the battery right in here with the solar charge controller. So a nice thing about this, I can be basically charging my battery and using it at the same time. It's called pass-through charging. Here's a side view of it. You can see the battery box, the solar charge controller, and the MC4 connectors. And one connector here and another connector going actually into the radio, which is right here. This is my meter that I put on here. So I'm actually able to know how much power I'm actually putting in from my solar panels into the battery, which is inside here. It's a 30 amp hour BioEno battery. And so this is actually coming in. This is my input charging, and this is my output going up to my radio with my inline fuses right in here. And here's the solar charge controller again. Really small, very lightweight, all fits right in the box. So from my PowerWorks meter here, I'm actually pulling 123 watts off of a 120 watt rated panel. The reason is this is like near noon, 11:20 a.m. Eastern Standard Time. It's cool. It's 67 degrees, sunny skies. When you get cooler temperatures and sunny skies, it's very common to basically exceed the wattage if your angle of the panels are set correctly. If you have it laying on the ground, I wouldn't be get 123. My solar panels have adjustable kickstands, which I really like, and that's one of the key reasons I bought it. And that's why I'm able to get 123 watts out of it because of the cooler temperatures, the correct angle, and it just works beautifully. So hopefully this is going to kind of help you understand, how what a real setup looks like, how it works, and what I'm using. And I really like it and would recommend it. But based on your budgets, you got to do what you got to do. And I always say something's better than nothing. Let's kind of go over some tips and tricks of when solar is not available, which could be quite often depending on the area that you live in. Nice is to have like a small little generator. You can get these for like $380, and you can, if you got money, you can go up to 1,200, like on the Honda version of these. But essentially, what you want to do is run the generator for a few hours and charge your multiple batteries at the same time, charge your laptop, and then shut it off. And so, if you don't have days without solar, or excuse me, days without the sun and you're in a cloudy environment, this can keep you up and going and cover you for a while. If you do, when the power comes back on, make sure that you have a battery charger and make sure that the output of the battery charger is compatible with the battery itself, that you don't damage the battery. They're not all the same. And for me, I just have extra batteries. So if I go through periods of time, I can just pull out another battery and get me by for a few more days until the sun comes back out and I can charge all of the batteries in there. And the way I look at it is, whatever you buy today, I guarantee you is going to be less expensive than in a couple months from now because inflation is not going away. And look at it as an investment for the unexpected. How much would you be willing to spend at the time when you don't have power and you can't get on and you've spent all that money in your ham radio equipment and you're sitting there looking at it and you can't use it? And especially if it's a protracted period of time and things are bad, you want information, you're all trained, but you got no power. Captain, I got no power. As far as me doing a part two, which I was going to do and to do a deeper dive, that's not going to happen based on my neurological condition. So I did the next best thing. I spent a lot of time putting together a document, comprehensive document with all of the information that you would ever want. And well, no, I actually even have a deeper dive document I'm working on because I got into solar. I found it interesting. But this is enough for you to really get your feet wet and understand all the terminologies and everything so that you can get started and have fun. And it's a great jumping off point. Again, you can just email me and ask for that handout. So I have multiple handouts. I have a deep dive document going over solar panels, batteries, solar chargers, inverters, and I have my basic and setup diagrams that I will include if you email me. And I just ask one thing, just hit the like and the subscribe button, and so others can find this information a little easier and faster. I appreciate that. So in summary, you don't always need solar, especially if you're doing QRP for short trips. But if you're doing extended time in the field, you're going to want to bring your solar gear. And you want to make sure that you're using the portable options, the size of the panel, and the weight, and the size of the battery, and have all of this together packed so it's easy to take in and out into the field. And always make sure you check the specs to match up with the equipment. That is I call it the hardest thing was for me was to try to determine what solar panel output works best with what size controller without overpricing myself or undersizing the solar controller and matches up with the battery specs correctly. And that's in my documents. Test and practice, make sure you understand how long it takes to recharge your batteries, what works and what doesn't work, and do fine adjustments and improvements. And expect cloudy days, and you have to learn to manage your power demands. Again, listening hardly uses any power. It's your transmission. So monitor and manage the transmission loads and the time that you use when you're transmitting on your ham radio. As far as a quick health update, I have been improving from a few months back when all of this started. However, I do have another surgery scheduled in May, and constant exposure to high pain levels, anesthesia, antibiotics is basically a sledgehammer to my brain, and that's what's causing these concussion stroke-like symptoms, and they've all been ruled out. That's not what I have, but I'm an enigma, which is pretty normal for me. Anyhow, I expect a setback, but with prayer, all things are possible. And I thank you guys who have been offering prayers, and they have brought me this far. Who knows? Let's see what happens after the next round of surgeries. So this is MJ, KW3KW with Ham Radio Made Simple. Glad I could do at least one more video, and appreciate those who hit the like and the subscribe buttons, and for your wonderful comments and thoughts and prayers. This is MJ, out.